In this video, we'll focus on graphing an absolute value function. The absolute value describes the distance from 0 that a number is on the number line without considering direction. Since distance is greater than or equal to 0, the absolute value makes positive whatever number is plugged into it. Here's an example. We are given g of x equals the absolute value of negative 1/3 x minus 12, and we want to find g of 12. So to plug a number into a function, we're going to put 12 in everywhere we see x. So we'll have g of 12 equals the absolute value of negative 1/3 times 12. Instead of an x, I'm writing a 12 because I'm doing g of 12, and then minus 12. Now we know that when we're multiplying a fraction times a whole number, only the numerator gets multiplied. So this is the same as 12 over 3. So it's the same as a negative 4. So 1/3 times 12 gives us 4, and it's a negative because of the negative in front. So negative 4 minus 12. So I get the absolute value of negative 16, but an absolute value makes positive whatever number is plugged into it. So my final answer would be a positive 16. And so g of 12 is equal to 16. So that's how the absolute value works. And now we want to graph absolute value functions. Absolute value graphs have a upward V shape or a downward V shape. For y equals a times the absolute value of x plus b, the vertex occurs at x equals 0. For y equals a times the absolute value of quantity x minus b, the vertex occurs at the x value that makes x minus b equal 0. To graph the absolute value function, plot the vertex, then one point to the left and one point to the right, and then connect the vertex and the left-hand point with a ray, connect the vertex and the right-hand point with a ray. So remember the vertex part. If there's only an x in the absolute value, then the vertex occurs when x equals 0. And if there's an expression x minus b inside of the absolute value, then the vertex is going to occur at x equals b. Here's an example. I have y equals 5 absolute value of x minus 2. So the first thing I want to do is find the vertex. And the vertex will happen when x minus 2 equals 0, because x minus 2 is what's plugged into the absolute value. So this gives me x equals 2. And to find the y value, I'm going to plug 2 in for x. So I get 5 absolute value of 2 minus 2. That's 5 absolute value of 0, which is 5 times 0. Absolute value of 0 is just 0. So the vertex is going to occur when x is 2 and y is 0. So let me go ahead and plot that point. 2, 0. Now I want one point to the left and one point to the right. I'm just going to go ahead and move over one spot to the left. So I'll do x equals 1. And one spot to the right would be x equals 3. And I'm going to get my y value by plugging those x's into the function. So I get y equals 5 absolute value of 1 minus 2. 1 minus 2 is -1, so 5 times absolute value of -1. But an absolute value makes positive whatever is inside. So this would just be 5 times +1. So 5. So I have the point 1, 5. And I'll go ahead and plot that. When x equals 3, I have y equals 5 absolute value of 3 minus 2. 3 minus 2 is a 1, so I have 5 absolute value of 1, which is 5 times 1, which gives me a 5. So I also have the point x equals 3, y equals 5. Let me go ahead and plot that. 3, 5. And once I have those plotted, I would just connect them with a ray. So I'm going to go ahead and start at the vertex, connect with the left-hand point, do the same thing, start at the vertex, connect with the right-hand point. And in this case, it's an upward-facing V because the coefficient in front is a positive. That 5 is a positive. So that would be my graph of the absolute value function y equals 5 absolute value x minus 2. Okay, let me go ahead and do another example. We have y equals 6 absolute value of x, and then minus 3 outside of the absolute value sign. So just like before, the first thing I want to do is find the vertex. I take whatever's plugged into the absolute value and set it equal to 0. So the vertex happens when x equals 0, and y is going to equal 6 absolute value of 0 minus 3, which just gives me a -3. So the vertex happens at 0, -3. So I plot that point, 0, -3. Now I need 1 point to the left. So let me try x equals -1. And 1 point to the right of the vertex. So I'll do x equals +1. When x equals -1, I'll have y equals 6 absolute value of -1 minus 3. But absolute value just makes that -1 a positive. So 6 times 1 minus 3. 6 minus 3 is 3. So I have the point -1, 3. And I'll do the same thing when x is +1. I get y equals 6 absolute value of 1 minus 3. Which just gives me 6 minus 3, or +3. So I have the point 1, 3. Notice in both of the cases, I have symmetry across the vertex, across the vertical line that passes through the vertex. So when I graph, I'll actually end up with that same y value, as long as I've gone out the same number of spaces to the left as I do to the right, I'll end up with the same y value for these two. Okay, so starting at the vertex, connect the vertex with the left-hand point. And then do the same thing starting at the vertex, connect the vertex with the right-hand point, and you'll get your absolute value graph.